Hello. I'm having some issues with my volume, so if it's difficult to hear, I apologize, but I promise to buy a new microphone. So today we're going to work on math rules. Okay, so these math rules are true no matter what you're applying it to. So these will stay true forever, ever. So the hardest math problem you've ever seen probably is 1 plus 2 equals... and it equals 3. This is 2 plus 1. Okay, so watch what I do. 2 plus 1. Oh, whoa, did you see that? Okay, so it doesn't matter what side I put it on. If I do 2 plus 1 or 1 plus 2, it's still going to equal 3. Okay, so that means I can switch addition, all right? And so what happens is, these are fact families. This is what I'm going to write as a little fact family list here. And my fact family list is going to have only these numbers. So I'm going to come up with 2 subtraction problems that only come up with these numbers. Okay? So I would have to start with the biggest number. And the biggest number is 3. So if I have 1 and 2 and they equal 3, 1 plus 2 is 3, 2 plus 1 is 3. Well, then I have to take 3. If I take away 2, if I take away this 2, I'm going to get 1. Okay, so 3 minus 2 is 1. So really, it's just that backwards. And if I have 3 minus 1, then I'll have 2. So 3 minus 2 is 1. 3 minus 1 is 2. Okay, so I don't even have to think about these if I know the math fact. If I know, let's say 2 plus 3 equals 5. I don't even have to think about that. I know that 5 minus 3 equals 2, and 5 minus 2 equals 3, and 3 plus 2 equals 5 because I know the rule, and the rule is I can switch addition, but I cannot switch subtraction, and I'm going to prove that to you. You cannot switch subtraction. So 3 minus 2 equals 1. Let's see what happens if I switch these. I have 3 minus 2 and it equals 1. Let's switch it. The question is this a true statement? Well, 3 minus 2 is 1. This one checks out. It is a true statement. But if I have 2 minus 3, 1, 2, oh, I get to 0. It's actually a negative number. So if I have... They tell you all the way through math you cannot subtract. You can't. So 2 minus 3, 2 is smaller than 3, so I can't take away. I can't do it. And especially when you're doing this up and down math like this, 3 minus 9, I definitely can't do because I have 3. Hold up, 3. Can I take away 9? Well, I only have 3 fingers, so I can't do that because I know this number is bigger. So I need to borrow. I go, hey, buddy, can I borrow one of your 10s? And he says, sure. And he becomes a 10 because he was 2, but I'm going to borrow. That's still 2 10s. I'm just moving it over. So the number didn't change. I still have 10, 23 up here. It's just that I moved how I did that. And I have a whole subtraction video if you don't understand the borrowing method there. But this is what it becomes. It becomes 13 and a 1. So 13 minus 9 is 4. And 1 minus 1 is 0. Okay, so you have to borrow, and they tell you 3 minus 9, you can't do it because this one is smaller, this one is smaller, and I can't switch subtraction. So 2 minus 3 is 1. Let's do that. This is a positive 2. Really, I'm going into negative numbers. So 2 is where I'm going to start, and I'm going to take away 3. So that means I'm going to go that direction, 3 spaces. 1, 2, 3, it's actually negative 1. There's a big difference between 1 and negative 1. If I owe you $1 and you owe me $1, that's 2 very different things, okay? So that means one of us has a debt and the other one has money, okay? So that's how negative numbers are. You think of them as debt. So 2 minus 3 is a negative number. This is not in this fact family. Negative 1 is not in here. Let me show you what 3 minus 2 looks like. 3, 1, 2, I'm here. These are 2 very different numbers, okay? So I cannot switch subtraction. It's not the same, okay? And so you never want to try to do that. And so on these ones, teaching the commutative property, that is these two numbers, 1 plus 2 and 2 plus 1, they can switch. Okay, so I'm going to use these dice to show you that if I told you to count everything that's on these dice, you would be overwhelmed. You'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20. Okay, it's going to take me forever to count all these dice, okay? So I don't want to do that, all right? So what I'm going to do is use a strategy, and that's what this lesson's teaching you, is how to use a strategy. So let me see. All right, the ways to get to 10 are, I can do 5 and 5, okay, with the dice, okay? Another way to get to 10 is going to be 6 and 4, 7 and 3, 8 and 2, 9 and 1. Did you see what happened here? 4, 3, 2, 1. They go kind of in order. That's because if I have 5 and 5, if I took this one here and put it here, I would have 4 here and 6. They were always the same number, just like with the 2 and the 1, okay? 6 and 4. But that's all I can do with dice, right? I can only do 6 and 4 and 5 and 5 because I don't have a 7, and I don't have an 8, and I don't have a 9. But I'm going to show you something else. These are ways to get to 10. Ways to get to 5 are 2 and 3 and 4 and 1. So I'm going to show you 2 and 3. All right. So if I have 2 and 3, 2 and 3, this is 5 and 5. These things are equal. This is 5, and this is 5. 1, 2, 3, 4, 5. Okay. Do you see that 2 and 3 and 2 and 3 is 6 and 4 also? So it has a lot to do with how you're looking at it. And if I have, let's say I have 6 and 4, and I can't make a 6, so I just use this. Can you see how that is also 7 and 3, 4, 5, 6, 7, 8, 9, 10, also a way to get to 10. And let's say that I don't have, with my 6 and 4, I don't have a 4, and I use this. This is also 8, 6, 7, 8, 9, 10. This 8 and 2. Okay, so there's lots of different ways with the dice to get there. And so I teach people the dice game. Get some dice. And I don't know if I made this up or if it's something that I saw somewhere. I'm pretty sure I made it up. We do this all the time. It's a really fun game. So we see who can get there faster, and I can show you. I can get there pretty quickly. And this is my strategy. The strategy is to take all your 5 and 5s first, okay? And I don't have any other 5s. So I'm going to take 6 and 4s. Just make, oops, that was a 6. Okay, 6 and 4. 6 and 4. Oops. I'm horrible at this. Okay, 6 and 4. Okay, now I'm down to these small ones, and I'm going to take 6 and 4. 6 and 4. Oops, I'm out of the line a little bit. 6 and 4. Okay. And then I have 3, 4. Oh, look, it makes a perfect 5. So what I do is, then I go 10, 20, 30, 40, 50, 60, 70. 10, 20, 30, 40, 50, 60, 70. Okay, and that's how I count them. So I'm grouping them based on 10s because I know how to get to 10s and 5s easily. It makes it easier to count the dice. I'm not going 1, 2, 3, 4, 5, 6, 7, 8. Okay, I don't have to do all that. And that's what this lesson's teaching you, that if I can group something based on grouping by 5s and 10s, then I can make it easier on myself. All right, sorry, I had to go get the book. I didn't remember where I had it. Okay, so if I have, the first part says, and I'm just going to skip to this one. If I have 4 plus 6 plus 9, and I have 9 plus 4 plus 6, I can do, and I'm going to go left to right, just like it says, okay? So I have to do 4 plus 6 first. Well, I know that 6 and 4 is 10, so this is 10 plus 9. But this one, if I did this part first, 9, 10, 11, 12, 13 plus 6, which one's easier to do? Well, this one is, because 10 plus 9, I know that's 19. That's pretty quick. And 13 plus 6 is also 19. So it doesn't matter what order I do it in, but one way is definitely easier than the other. Okay, so if I have 70 times 5, I can count by 5 70 times, and I'm not going to do that. I can add 75 times, and I don't want to do that. I can do this up and down math, but that's not what this lesson's about. I'm going to show you if I switch it, I might remember, oh, 5 times 7 with a 0 on the end. That's how I do that one. 5 times 7 is 35, and I stick a 0 on the end. Remember the 0 rule. Okay, and you don't have to switch it to see that, but if you know that rule, you can just say 7 times 5. Okay. The next section says, on section D, it says, use the commutative property to solve each problem mentally. So yes, you can add it up with the up and down method. This one wants you to use your brain and think about the answer. So if I know, so here's what I have. And don't forget that my ways to 10 are 5 and 5, 6 and 4, 7 and 3, 8 and 2, 9 and 1. So I see 8 and 2 here. The commutative property means I can switch these orders and it will still be the same problem. So I'll have 67 plus 8 plus 2. This is the same as this. These are equal. I'm setting them equal to one another. So 67 plus 8 plus 2 is 67 plus 10. And that gives us 77. Okay. Now, if I wanted to do this just straight left to right, I could do 67 plus 8. 8 and 8 is 16. 7 and 8 is 15. 6 and 1 is 7 plus 2. And that gives me 77. Now, I can do this problem this way, but this is wanting me to do it this way. Okay, so that I can find quick ways to answer, just like when I was using the dice. All right, the next one says 45 plus 26 plus 4. Well, now I see this 6 and 4 here, but this 6 is connected to this 2, and I really don't have to switch the order, but I do need to look at it a different way. I'm going to look at it this way. 45 plus 20 plus 6 plus 4, and 6 and 4 is 10, so I have 45 plus 20 plus 10, 45, 55, 65, 75. Now, if I had done this way, I'm going to show you what that would look like. 45 plus 26. 5 and 5 is 10. 6 and 5 is 11. 4 plus 1 is 5. Plus 2 is 7. Okay, this is 71. And then I need to add my 4 in to get to the 75. So I'm going to add 4. 1 plus 4 is 5. And 7, 75. Now, they may be equally as long for you right now because you haven't really got this method down. But once you get it down, this is going to be much quicker. Okay, 17 plus 47 plus 23. All right, 17 plus 47 plus 23. What do I see here? I see 7 and 3. Can you see 7 and 3? And actually, we have one here too. Let's do these two together because actually I want to start with my big number because that way I'm not adding big things. You know, if you start with the biggest number, it makes it super easy. Like this one, I started with my biggest number. It makes it easier to count. So 47, I'm sorry, plus 17 plus 23, and I switched it. That means that's the commutative property. And then I'll have 47 plus 10 plus 7 plus 20 plus 3. All right, and so I'm just going to switch these two because these two will put the tens into the ones that have tens, whole number tens together, and the ones together. Okay, so all I did was switch these two. Same problem. Okay, and I know 7 and 3 is 10, so I'm going to have 47 plus 10 plus 20 plus 10. This is 47, 57, 67, 77, 87. Okay, so yes, this takes a little more time. Now, all of this really, I could have done all this step and this step you know, in my head and come up with this. I could have done 47 and then 7 and 3. I would have just done 47, 57, 67, 80, 47, 57, 67, 77, 87. Now, I could have just done that in my head quickly, but I wanted you to see that there's steps that happen in your brain. It's not like I just looked at this the first time I saw this and I had to go, okay, well, I just go do boop, 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 boop. Most people don't do that. Most people, they go through a thought process and then they go, oh, okay, this 7 and this 3, they go together. And then this is 10s and I'm making 10s. So that thinking process is going to become more natural to you. This is one of my favorite ones because it shows you something pretty interesting. So I know that 5 and 5 make 10, so I want to get these guys together. So I'm going to do 55 plus 45 plus 39. All right, and then I've got this 5 and 5 together. So I have 50 plus 5 plus 40 plus 5 plus 39. All right, I'm going to just switch these two guys because that puts all my single numbers together, single digit numbers, and my double digit numbers together. So I'll have 50 plus 40 plus 10 plus 39. And sometimes kids try to do it really difficult. They try to add these two. Well, try to add these two together. Make another 50. That makes a whole number. And I know that 50 plus 50 is 39. So this is 100 plus 39 is 139. Okay, you don't have to write all this out, but if you get the idea, you know, if I did this, okay, these 3 steps, and you don't have to write this step either. So if I wrote this step, and this step, that kind of puts down that I've showed my work and I know how to get to the answer. Okay, so I could have done 55 plus 39. All right, 55 plus 39, 9 and 5 is 14. 5, 6, 7, 8, and 9, 94. Okay, then I have to add 45 to it, and 5 and 4 is 9, 9 and 4, this is 13. All right, now I could have gotten it that way, but this really is easier if you just start to think about it. The next has multiplication, and this part's pretty simple. I'm just going to try to get to multiplying by numbers that get to a whole number 10. So this is this way. I'm going to write 5 times 2 times 9. And 5 times 2 is 10, times 9 is 90, okay? That's how you do lesson 33. And it does take a little bit longer, so I apologize. This video is a little longer, but I wanted to make sure that you saw, even if it's quick, that you saw the steps to get to the answer. And then I'll do lesson 34 next.